factor, the myelin basic protein, SOX10, SOX2, all these things shows that the expression of proteins, the nerve proteins are increasing. And these are the protein expression by immunofluorescence assays. These also shows that the proteins are expressed. That means the nerve is growing. And then we did the in vivo studies on the Sprague-Lowry rats. And these are sciatic nerve disruption. And further we did the functional recovery analysis. There we did hot plate test, gait analysis, walking track analysis, and rotational running test. Everything shows that the green one is the enhanced recovery of the recovery analysis of the nerve growth factor. And this one is functional evaluation using the electromyography. And we use the electromyography and the nerve conduction velocity test. Both shows that this one is better. And finally, the immunohistochemical assays also shows that as time goes, the nerve is growing faster. And these are the conclusions. And this is the sensing we have done, which was, so we expect that this kind of nerve intraluminal channels conduits can little bit, at least enhance the cell proliferation and cell signaling compared to the alone nerve conduit. Thank you. And this is based on our experience. We plan to start an initiative using MSME, and this is our logo. Thank you very much.
Good talk, Dr. Shalimar. I have a question about the PCL. So, since PCL don't degrade, I just wonder, interesting to see the design, why PCL was chosen?
Because since we need the intraluminal channels, the polycaprolactone is one of the best material to make the nanofibrous bundles. Rest of the polymers like PLG, if you select PLG, this is very fast degrading. And if you select PLA, this is very fast, relatively faster degrading. And yield of these nanofibrous bundles is also very less. PCL, we can make the bundles very fast, and we can make the nanofibrous bundles more. So in 1 minute, we can make at least 4 or 5 meters of nanofibrous bundles using PCL. And also, since the nerve growth factor, this nerve growing speed is also very less. We need that scaffold to stay back for some time. And later, since the gelatin cryogel conduit is there, that is degrading faster. Once the gelatin cryogel conduit is degrading faster, then this will come to expose the outer side very fast. Then it will degrade slowly. We need this nerve, it's like bond kind of thing. It will not, since the remyelination process is very slower, we need that cables connecting the proximal and distal end for some time in our peripheral nerve.
Wonderful work. Just out of curiosity, how long does it take to bridge the critical size defect in the rat model?
Actually, since we are adding Schwann cells directly, and this expression is actually very, very fast. That's why we are getting in 7 days, since Schwann cells expressing its proteins after 3 days. So 7 days itself, we can see the Schwann cells expression proteins, everything. We did it up to 12 weeks. All the in vivo studies we did, all the functional recovery analysis, rota-rot, everything we did it in 12 weeks. Like, for example, this one, everything is 12 weeks. We will allow the rat to run on the rota-rot so that if it is recovered, the rat will fall down. We can count the timing. The other one is if the fingers, if the nerves are formed very well, it will walk properly so that we can measure the toe length, and the other one is stride length. Stride is in between the 2 consecutive steps. So if the rat is normal, if the foots are normal, if the regeneration is normal, the distance between both of the legs will be the same.
Okay.
So this is how we are doing.
Okay, thank you. Thank you.
Thank you very much.
We come to the last speaker of the session, Mr. Roshan Kesari. He is a research scholar at IIT Bombay. The title of his presentation is Eugenol-loaded lipid nanoparticles, derived hydrogels, psoriasis-like skin lesions by lowering oxidative stress and modulating inflammation.
So very good afternoon to all. I am Dr. Roshan Kesri. I have recently completed my PhD just 2 months back under supervision of Professor Rohit Srivastava, and currently I am also a postdoctoral fellow at the same institute under supervision of Professor Rohit Srivastava. So today I am going to explain one of the most award-winning and influential PhD project entitled Phyto-Nanogel Shield Eugenol Loaded Lipid Nanoparticle for Precision Care in Psoriasis Management through Oxidative Stress and Modulating Inflammation Modulation. So I would like to start with a very brief introduction of psoriasis. So it is an autoimmune disorder. There are a lot of treatment regimes are available in the market, but none of them are competent to cure. It can only be controlled to some extent. So for example, if in normal individual, the skin shred occur in every 30 days, but in same individual, in psoriasis patient, it occur in every 2 to 3 days. So there is a pilation of skin cells and the skin becomes very thick. So this is the current future market of psoriasis. See, here we can see, sorry, which one is pointer? So here we can see in 2025, the current market gap is $34.14 billion. But when we reach to 2032, the same market gap is $58.5 billion. The reason behind this is that this disease cannot be treated. It can only be controlled. And patients have to apply longer and longer duration medicines. And just because of this, they are suffer from different kind of disease. I have shared my room with the psoriasis patient, and I know how the person feels. They have to apply multiple medication throughout the day, and they have a lot of comorbidities along with the heart disease, lipid disturbance. So there is a requirement of some of the innovation in this disease. So we came up with the novel idea. Here, this is the graphical presentation of overall idea of my project. We selected all the FDA approved and easily available product. We prepared soy lecithin, tocopherol, TPGS. We prepared blank nanoparticle. In that blank nanoparticle, we encapsulated eugenol, that's a phytochemical drug, and later on we converted into the nanoparticle, and later on we have converted into gel, and we applied on mice skin. And after applying on mice skin for 6 days, there was a reduction in PASI score. PASI score means psoriasis area severity index, and we did a very extensive animal study along with the cell culture study to prove our hypothesis. Since there are tons of data available, but I'll be only explaining very few data. The size of this nanoparticle is approximately 220 nanometer, so that through the hair follicle, it can easily penetrate through the skin, and it was spherical in size, and it was negatively negatively charged. Along with the most important thing is that in psoriasis patient, they have to apply medicine for multiple time, means after each and every 3 hours, 4 hours. But when my formulation will be applied, it will work just one application, and it will work for 48 hours to 72 hours. There is no other dose you have to apply for it, and it will show a better therapeutic efficacy as compared to the available marketed formulation. So we did a very extensive cell culture study, but here I am showing only few data. This is pointer is not okay. So pointer is, so this is the we did a study in healthy scale and healthy cells along with the IL-6 in inflammatory cells. And here we can see that in inflammatory cells, there was a better uptake of my nanoparticle as compared to the healthy cells. So from here we can saw that okay, my nanoparticle is working very well. It can easily be taken up by the IL-6 induced cells. Since in psoriasis patient, these IL-6, IL-7, TNF-alpha, IFN-GAFA, IL-6, and 10, these are widely expressed. So we use IL-6 as a model. Moving towards the next step, since psoriasis patients are also expressed over ROS. So we did a very extensive ROS study. We did in mice skin, we also did through DCFD assay, and we also performed through TMRD. And all the treatment group, here we can see that in EUNPL group, the intensity is low as compared to the other treatment group. Moving towards the next step, it is necessary to understand whether my formulation is working on the skin or not. So we did ex vivo study on the through plant diffusion apparatus by isolating a skin from the psoriatic mice skin, and here we can see that both in epidermis and dermis, along with the receiver compartment, there was a better penetration of drug as compared to the free gel. So here we got to know, okay, my formulation is working well. Now we did the IVIS imaging, and after that we did in vivo study on imiquimod induced psoriasis scale. Here we can see that so I think pointer is not working. Here you can see the PASI score. PASI score was very low as compared to the other treatment group. Since in immune system, the weight of spleen is very increases. Here we can see that in a nearby scale, the weight of spleen positive control was very thick, high, but in the treatment group, the weight was almost similar to the positive control. So this was the histopathological data. We did a very deep histological study, and since I was not able to accommodate all the images, so I just gave a scoring. Here we can say that UNPGEL was my final formulation. The scoring was very less as compared to all the other treatment group in eugenol free gel and positive control IMQ, which is widely used to induce psoriasis and negative control. My formulation was better as compared to the other treatment group. Similarly, we also did the histological study of spleen and tissue. This is the conclusion. In conclusion, I can say that we have developed such kind of formulation which can work for 48 hours just in one application. Otherwise, the formulation which is available in market, it's not, we have to apply for every 3 and 4 hours. Along with that, there is a lot of comorbidities. Based on this, the paper was already published in ACS Pharmacology and Translational Science. Patent has been already granted in 2023, and this project was awarded by the Gandhi Young Technology Innovation Award by Principal Scientific Advisor, Government of India, along with the DBT Secretary, and it was widely in all over the newspaper. Based on this project, in 2020, my entire PhD project was funded by DAAD Germany, and this was another award by outstanding contribution to pharmaceutical research by Academic Institute IIT Bombay, and this is outstanding PhD thesis award from the Society of Biomedical and Artificial Organs, and this is the next award I was nominated. This project was nominated for Modi Prix Galleon Award. The final function is going to be held at March 20 in Taj, New Delhi. So this is one of my PhD project, and sorry for taking 20 or 1 minute extra. I apologize for this, and this pointer is not working. I was supposed to focus on some of the things, but it was not working. It's okay.
Very, very impressive work. I have a question. Your drug release in vitro shows
Come again, ma'am.
Sorry. Can you hear me?
Yeah, I can hear now.
So your drug release in vitro shows about a few hours of release, but your in vivo, I think, outcome shows 48 to 72 hours. So can you elaborate on why that prolonged effect was observed?
In vitro study, we did, there was a 48 hours till 40 to 72 hours. But in vivo study, we also did for 24 hours. And there might be some difference between the in vitro and vivo, but till 24 hours, we performed this study and we got a good result, which we showed in ex vivo through plant diffusion apparatus.
Oh, I thought your in vitro study shows few hours, 2 to 4 hours.
Yeah, 3 to 24 hours. We tried to do for
100% release that quickly.
Yeah.
Okay, thank you.
Roshan, very interesting work.
Thank you, sir.
Why did you pick eugenol? What was the thought process behind that?
Actually, the reason behind this is that though there are a lot of formulations, corticosteroids are available, and I have closely seen the psoriasis patient. During my entire full-year bachelor, there are no any other formulation available in the market. And eugenol they have very good efficacy. They are very good in controlling cytokines levels, and there are a lot of studies. And these are anti-inflammatory, along with the anti-nociceptive, and sometimes it's also antidepressant. So I try to select such kind of drug which can I can get collective effort. Because in psoriasis, I have to control inflammation, I have to control, I have to get anti-nociceptive effect, and sometimes I have to also get antibacterial infection, because psoriasis patient, sometimes they also get a bacterial infection, because there is a formation of wound, because the skins are always open, red. So that's why I selected eugenol. And along with that, as I was from Srivastava lab, and we have also a thing that the work which I did, it should be in market. So I selected such kind of drug which can be easily scalable, and it's very cheap. Last time, just for 30 seconds, last time when I was in Delhi in front of Professor Ajay Sood, he also asked me same question. I said, if I launch this product in market, in 10,000 I can produce 1 kilo of 1 kilo of hydrogel, and it will be one of the biggest breakthrough in the psoriasis management, because very easily available 1 kilo in just 10,000 without the use of any sophisticated high instrument, just a high-speed homogenizer. It's very easily available. You can also make with through magnetic on stirrer.
Okay, thank you.
Any other questions?
No, thanks.
Thank you, everyone. Though the session was light talk session, the amount of work that was done was quite heavy. So I congratulate all the speakers, and we end this particular session. We have two announcements. First announcement is the poster session is yet to be evaluated. Requesting the poster session people who are involved in that to be there in the amphitheater in Simsar now after this session. And the second one is those who are to do their presentations tomorrow, kindly see to it that your presentations are uploaded, maybe latest by tomorrow early morning. Thank you.
Okay, we're done, right? आपका phone है.